containers that hold chemicals, protect equipment, all garbage, toys for children and adults, medical instruments, and farm implements. Large and small parts, complex shapes, and plain ones. Diverse products, yet all created by a single process, rotational molding. Rotational molding is actually a very simple low-pressure process for making hollow parts. It starts with a good quality mold. The most common, like this one, are cast from aluminum. Others may be made from sheet metal. The molds are placed in a molding machine that has a loading, heating, and cooling area. Several molds may be placed in this frame at the same time. Pre-measured plastic resin is loaded into each mold. The molds move into the oven, which is heated at 500 to 700 degrees. Inside, they rotate slowly on both the vertical and horizontal axis. The melting resin sticks to the hot mold and coats every surface evenly. The part forms to the mold, while the inside remains hollow. The molds continue to rotate during cooling so that the parts retain an even wall thickness. When the parts are cooled, they are demolded. The rotational speed, heating, and cooling time are controlled throughout the process. The carefully thought-out design can minimize the finishing required for a part, and there are a number of finishing and secondary operations available to designers. Routed, saw cutting, drilling, trimming, labeling, flame polishing, and component assembly. Rotational molding offers design and cost advantages that other molding processes can't. Designers, for example, can convert parts made from more traditional and expensive materials, such as wood, metal, glass, or fiberglass, to lightweight and less expensive plastic. The process lends itself to a variety of hollow forms, from small to large. In fact, the larger the better. Rotational molding easily produces large parts that injection and blow molding can't produce as cost-effectively. With the proper design, parts that are now assembled from several pieces can be molded as one part, eliminating expensive fabrication costs. The rotational molding process has a number of inherent design strengths, like consistent wall thickness, with good load-bearing capability. Rotomolding produces strong outside corners that are virtually stress-free when compared with other molding processes. For added strength, reinforcing ribs can be designed into the part. Designers can select the best material for their application, specify additives that will help make it weather-resistant, flame-retardant, or static-free. Choose colors. Rotomolding delivers the product the designer envisions. They can specify inserts, threads, handles, or minor undercuts as part of the design. Design parts with plain flat surfaces that eliminate draft angles or specify fine surface detail. Choose multi-wall moldings that are hollow or foam-filled. Even design parts molded as one piece, then cut them apart to form a cover or base. All this while holding tolerances to within 10,000ths inch per inch. When cost is a factor, rotational molding has the advantage over other types of molding processes. Tooling is less expensive because there's no internal core to manufacture. Large molds are less costly. And because parts are formed by heat and rotation rather than pressure, these molds don't need to be engineered to withstand the higher pressures that injection and blow molds do. Since there is no internal core, minor changes can easily be made to an existing mold. Production costs are reduced because lightweight plastics replace heavier, often more costly materials, which makes rotomolding as cost-effective for one-of-a-kind prototypes as it is for large production runs. Design and cost advantages position rotational molding as a strong alternative to other molding processes, a position that the Association of Rotational Molders works to improve. Research on new materials, advanced manufacturing techniques, and unusual applications is accomplished through the Rotational Molding Development Center, founded by the Association of Rotational Molders. Located at the association's headquarters in Oak Brook, Illinois, this division of ARM is dedicated to keeping rotational molding at the forefront of the plastics molding industry. Simple, flexible, cost-effective. These benefits make rotational molding the fastest growing process in the plastics molding industry, and they can make your job much easier. Whether you're designing a new product or converting an existing one, consider rotational molding. The possibilities are, well, unlimited. If you would like to hear more about the unlimited possibilities of rotational molding, write or call the Association of Rotational Molders,